Hello, welcome to the first of the reviews of these digital online quizzes that we've had. So this is quiz 4, the mechanical systems quiz. I just thought I'd go over it quickly and talk about the correct answers and why they are what they are. So question 1, we've got a mass with a pair of dampers and a pair of springs, and the input Y comes in through the spring and the damper. And first, we want to figure out, all right, which of these free body diagrams is appropriate for this mass. In truth, right, we can have the force arrows can go in any direction, it doesn't matter, but we are not allowed to reverse the coordinate system. That has to be the same. So what we see here is, okay, A is looking pretty good. We see that there's a force due to spring 2, there's a force due to damper 2, a force due to damper 1 and spring 1. And then the coordinate system, X here is in the correct direction. So A is clearly okay. B is clearly not okay because, well, the coordinate system is backwards. That's no good. As I look at C, okay, it looks pretty good. Yeah, everything looks fine here. Things are the X is in the positive direction. That's fine. And we're allowed to reverse. We're allowed to reverse the arrows here, but we are not allowed to reverse the coordinate system. When I look over here at D, well, the coordinate system is fine. That's good. But if I look carefully, I have reversed, oh dear, the 1s and the 2s. So that's not going to go well. Yeah, because the B1 and the K1 were on top, the 2s are on the bottom, so that's no good. Yep, so A and C are okay. Okay, now let's move on to question 2. So in the system shown below, we choose to sketch a free body diagram. All right, so I've said, all right, I've taken this free body diagram from the last question. So there's a huge clue, right, that one was okay. Which of the following is appropriate for spring 1? So we're just looking at this one spring here. All right, so the big clue here is that we have to have locked ourselves in for force direction on spring 1 at X. So here I've drawn it down. What that means is the only admissible spring 1 diagrams are going to have to show on this end, the force is going to have to be going up. So immediately we can rule out C. That's no good. All right, next. For spring 1, at the bottom, it's going to have X, and X has got to be going in the positive direction. Oh, so we can rule this out. Nope, A is not okay. We've ruled out C. C is not okay. B, all right, X is in the positive direction. FK1 is in the positive direction at the bottom. Okay, so this one's looking pretty good. Now we look at Y. Y is positive. Yep. So B looks pretty good. It looks like B is acceptable. Why isn't D acceptable? It's not, because oops, X and Y are reversed. So that would cause a negative sign to show up when it shouldn't be there. All right, so we're just left with B. Right. And you can see, of course, I took this as to proof it. All right, to preview it, I just went ahead and gave nonsense answers, so that was incorrect. Oops. All right, here, okay, now, so presumably we've applied that same thinking now to all 4 of these components, and now it's time to write an equation in this form. So the question is how should we write this? When you're done writing it out, here, let's switch to the camera and see what we can do. There we go. So when you're done writing it out, the form of the equation is mx double dot plus a x dot plus b x is equal to c y dot plus d y, right? Well, so we need to figure out what a, b, and c and d are, right? So just quickly writing my free body diagram here, and then we had, this was B1, this was K1, this is B2, this is K2, this is X, right? So the equation for my mass is mx double dot is equal to the sum of the forces. So I'm going to have a negative FB1, a negative FK1, a positive FB2, and a positive FK2. All right, so there it is. So now I just need to drop in my forces here. If you go through the process of writing the free body diagram, of drawing out the free body diagrams, what we're going to end up seeing, FB1 is going to end up being equal to, well, B1 times, there has to be it's going to be positive x dot minus y dot. And we're going to end up with something very similar for K1. And just to quickly go over why that's true, let's look at K1. Just to review why that's going to wind up being true. The forces ended up being in that direction. All right. So, and remember, we knew that was true. Remember why we knew the force was in this direction. It's because we drew it here on this free body diagram. We drew it negative here, and so it needs to be in the opposite direction here, right? So this is the x-coordinate system, so it shares this point in common. That means the forces need to be equal and opposite at that point. That's Newton's third law, right? Okay. So, yeah, when you look at this, so which terms are going to be positive? Remember, the x agrees with the force, so it's positive, and then the y opposes the force, right? So it's negative, right? So that, and the same, we would have gotten the same thing with the damper, right? So just don't forget your dots. All right. Well, when we follow that same process for B2 and K2, we end up with this. Because these are attached to ground, so they're not going anywhere. They only have one term that matters, and that's x. All right, so when all is said and done, we substitute. I'm going to go ahead and work this out. Since we're not in person and you can't tell me to yell at me to slow down if I skip over steps, I'll be a little more cautious in working through this. All right, so when I substitute this into here, I'm left with negative b1 x dot plus b1 y dot. All right, same story here. Negative k1 x plus b1 y. All right, similar, but not quite the same stories. Minus b2 x dot minus k2 x. Right, I'm keeping the minus from here, even though this was positive. Okay, so when all is said and done, the form we end up with, I'm forcing myself to put it into this form to make it look like this. So here we go. I need to group up all of my x dots. There are two of them, b1 and b2. b1 plus b2 x dot plus k1 plus k2 times x. Okay, so there's one here and one here. Let me put little check marks to remind myself that I've taken care of those terms. Equal to. This is a trick I actually use when I'm dealing with very long equations and I'm worried that I'm going to forget terms as I start checking them off to show that I've accounted for them in the next line. Was the first thing we wrote. Right, so on the right-hand side, there's only two terms left, which makes sense. Oops! That should have been a K1, sorry. So this will end up being B1 y dot plus K1. There we go, quite silly. All right, there we go. So we've got it. So A ends up being B1 plus B2. B ends up being K1 plus K2. C ends up being just B1. And then D ends up being just K1. Cool. And that's the story. Okay, so let's go back to the screen. Oop, not that one. There we go. When you do that, right? So here you can choose from these. So A we said was going to be positive B1 and positive B2, right? So that's the way we would fill that in. Okay, this one apparently I answered correctly. So yeah, there we go. So that actually carries us through the last of the questions, right? So that was quiz 1. So hopefully that was helpful. If you've got any additional questions, feel free to email me or show up to the Q&A sessions. All right, take care.